Thank you all for joining us for our SICSS-Howard Mathematica Lunchtime Talk with Will Kent from Wiki Education. During these chats while you chew, you'll meet interesting people or organizations that are doing cool and complementary work to what you're currently learning at the Summer Institute at Howard University. If you don't have your lunch yet, hit pause. For those of you with food and beverage in hand, let's get started.
Hi, everybody. My name is Will Kent, and I work for Wiki Education. I'll be presenting about Wikidata today and how it might affect your research or impact it in some way. So what I'm hoping to cover is a quick introduction to what Wikidata is, why it's important, how it can have an impact on your research, a little background about linked data, and some examples of Wikidata in action. So let's begin with what is Wikidata. You might have heard of it, you might not be familiar with it, but some quick background. Wikidata is a linked data repository for all Wikimedia projects. A Wikimedia project, you've probably heard of Wikipedia, but you might not know that there are 300 different language versions of Wikipedia, and as well some additional Wikimedia projects like Commons or Wiktionary. So a lot of different pieces of data floating around the internet are all united through Wikidata. Wikidata aims to represent every single Wikipedia article as linked data. So any article that exists on Wikipedia also exists within Wikidata. But it also goes beyond Wikipedia and tries to represent everything in the world as linked data. So there are things that may exist in Wikidata that don't yet exist in Wikipedia, which will be important for research in just a little bit. Continuing. Wikidata strives to describe things, people, and concepts with linked data. So if it exists, chances are it can be in Wikidata. And it does it through linked data. And linked data is a specific kind of data that excels at representing things as well as the relationships between things in a very structured way. And this will become important in just a little bit too. Linked data also happens to be very easy to use, reuse, and incorporate into other data sets. Either as a schema, so like a model for describing things like people, how you describe a person, or whole ontology, so how all of these pieces fit together in the data set world. And linked data has become central to the development of the semantic web. So Wikidata is a very significant part of the semantic web today. It also has become a hub of connections. So a lot of institutions, museums, libraries across the globe all use Wikidata to connect to their collections or catalogs. So why is Wikidata important? Wikidata is both human and machine readable. And this means that we can read it as people, but machines can also manipulate and edit it very quickly, which makes batch or automated editing possible. So instead of editing things one little bit at a time, you can do it on the scale of tens or hundreds of thousands of things at once. It can be easily rendered in any language. So through quick translation, it can exist across any language that you can imagine. And you can also run queries to answer very complex questions. So as you can imagine, representing the entire world as linked data will yield some insights that don't yet exist. So we're learning how to ask these complex questions of Wikidata. And since Wikidata is part of Wikipedia, it can analyze Wikipedia's data in new ways, either for maintenance or improvement. And we'll get to more about that in a little bit. Wikidata is important because it's free and open, so you can use the data, you can contribute data, and use a whole suite of tools associated with Wikidata to visualize and analyze the data itself. And as one of the largest free and structured data sets available online, big tech companies frequently use Wikidata and Wikipedia in search results, machine learning projects, and for training artificial intelligence. And as a result of this, Wikidata amplifies both the good and the bad of Wikipedia, systemic bias, equity, inequity, and both high and low quality content. So how does this impact research? Wikidata is open, so all content on Wikidata is available under a CC0 license. This means it's public domain, which means that you can use it for your research and you don't have to cite it. You can just use it as a data set and run algorithms through it. You can train artificial intelligence on it. You can select a little slice of data and keep it as yours. And it's worth noting that this is a broader license than Wikipedia, and it's less restrictive. So anything that exists on Wikidata is essentially yours. It is multilingual, so you can run projects in multiple languages. It also makes Wikidata more equitable and accessible globally because of its language independence. And so this is just a quick screenshot of the concept of chemistry on Wikidata. And you can see that in this little language box, the concept of chemistry is rendered in Spanish and Chinese and Arabic, among many, many others. This is just the top alphabetical wise list of languages. And it's a structured knowledge base, which means that it records details about concepts, but it also connects these concepts from other databases. So it can help disambiguate, it can help connect specific domain sets of data to this broader understanding of concepts, people, places, and things. And so here's just a quick rendering of how data looks on Wikidata. Edward Hopper's painting Nighthawks. You can see these different connections between these different arcs and nodes, kind of describing what these things are and how they relate to each other. Wikidata is also editable, so you can participate in it right now, and there are 25,000 active users currently. So it is interpretable by humans, and you can also add things to it, which is very important. And so this is just an example of how you can edit things on Wikidata. Just some quick background on how Wikidata is structured, and then we can get into some research examples. The basic building block of linked data is called a triple. You can think of it as a sentence, like a subject, verb, and an object, or a subject, predicate, and an object is kind of like the classical set of vocabulary that people use to describe the triple. But Wikidata uses a different set, which is an item, a property, and a value. And that's described right here. So an item is the thing we're talking about, the property is the relationship that connects the item to its value, which is just another thing. So I've pulled up an example here. This is an info box from Wikipedia from Howard University. And this Q number is the number for Howard. It's specifically and unique to Howard. And so that's highlighted right here. The relationship are these properties. So what kind of thing it is? It's a private historically Black research university. When was it established? March 2nd. 1867, and you can see that those are the values. So these are two examples of a semantic triple on Wikidata, and we use these statements, as they're called on Wikidata, to describe things. And this is what it looks like on Wikidata. Here's a beautiful screenshot, so you can see here's Howard, and that's the item. Here is the property, which is instance of, and here is historically Black colleges and universities, which is the value. So this just kind of sums up what I was talking about. You can have a lot of statements to describe items, and you should think of Wikidata as a set of facts rather than like a context providing tool, which is much more what Wikipedia does. So now that we have a kind of background of how Wikidata works, we can start to explore it on a deeper level, actually using Wikidata's data. And so you can run these complicated queries of all the data on Wikidata, again, for free, and use the data however you want. It uses a querying language called Sparkle. It's just different enough from SQL to be kind of a pain in the neck. So here is some more information about it. Sparkle is a protocol, an RDF query language. If you don't know what that means, that's quite all right. It just means that it can sift through a lot of linked data very quickly and return results that you want. We've never had this level of structured data at our fingertips before, so a lot of us are still trying to understand what questions to ask, which is where your research might come into things. And another very cool thing about linked data and Sparkle in particular is that there are different kinds of output for the data. You can render things as maps or as images, tables, and graphs. Another very cool thing is that you can download this data as JSON, TSV, CSV, or HTML format, which makes it extremely nimble in a lot of different kinds of programs. So let's jump into a couple examples right now. I've pulled up a Wikidata page for Dorothy B. Porter, who is a librarian at Howard University. And I just wanted to share this with you to show you what it looks like. So here is her picture. Here's a set of statements describing her. And if we scroll all the way down to the bottom, sorry, there's a lot of information here. You can see that there are these identifiers which connect to different libraries and museums and institutions across the world. So if we click into this, it would take us through to these other websites and resources that talk about her. So it's really easy to grab a lot of information about her. But we were talking about the query service. And so to get to it, we can just click query service over here. And this is the Wikidata query service. You can enter Sparkle language stuff in here, and if you don't know it, that's okay. I've pulled up an example for you, so this is already filled out. And what this set of code is going to do is pull in all of the additional information about Dorothy B. Porter from all these other libraries and museums. So I can run the query by pressing play. And you can see that here are a bunch of links to Library of Congress, to Google, to Gutenberg, and you can click through to any of these and learn more about her. So again, this kind of underscores the point that Wikidata is a connection hub for all of these institutions. And it's very accessible through the query service and also just through Wikidata pages. You can reuse and use this data again. And again, a lot of organizations and companies across the world are starting to point to Wikidata to grab all this information about different kinds of people. But these queries are also really easy to adapt. So I've pulled up another query here that's a little bit more general that talks about, or that asks Wikidata for people who went to Howard University. So this will just generate a list of people who are notable enough to be on Wikidata. And if I push the play button, it'll run the query. And in just a second or two, we can see we've got 2,000 results. And you'll notice that some names are repeated, and that's because I've also asked for their occupation. And if people have more than one occupation, they'll show up multiple times. So this is a really easy way to see some alumni of Howard University and what they've done in life. And it's a really cool way to start to analyze this data. You can ask Wikidata a lot of other things, but I just chose occupation because I think it's interesting. And it's a good place to start doing some analysis of alumni work. Additionally, I mentioned that Wikidata is tied to Wikipedia. So I'll just modify this query by activating this line right here and run it again. And if the person has a Wikipedia article associated with them, I've also pulled in the link to that Wikipedia article. So you can gather all of this here. And like I mentioned, you can download all of these results and plug it into a CSV file. You can analyze it using any sort of code that you want. You can also embed this using this code button in all of these different languages. So it will spit out this query in Python or in Ruby or in R or in HTML if you want to embed it on a website. But like I said, it's really easy to manipulate all of these different queries. So let's do this one more time. I've switched this query a little bit. It's going to give us the same information, so people who went to Howard, but it's going to display the results as a bubble graph, or just a regular graph, I guess is the term that Wikidata uses. And I've limited the results just to 100 people, so this should load fast enough and we'll finish by the time you're done eating lunch. So as you can see right here, here's a very pretty graph of bubbles and people who went to Howard University, which is centered there in the middle. And we can learn a lot about people just by clicking on him. So here is Dorothy B. Porter, and we can click on her, and you can see all of this additional information kind of appear, which is showing this data in action. And you can see a little bit more information about her and click through to her Wikidata page from here. But similarly, you can click on anybody else and get that set of information. And you can just tweak this query a little bit to have it represent anything else that you want to. And again, you can download these results. You can share them with people. You can parse them in new ways. So this is just one starting point for representing information on Wikidata. And you can also switch the view over here from this graph back to a table if you want and see it that way. And again, like I mentioned, you can see there'd be images and maps if we had coordinates, some area charts, bar charts, but I thought the graph was the coolest way to represent this sort of information. Moving along to another example, you can also, like I said, pull in additional sets of data or slices of data about certain things. So I wrote this query, and if we run it, you'll see in just a second some additional information about Howard, people who went to Howard, including people who have works in the collection at Howard. So you can see there's a lot about artists and journalists, and it's a great way to understand what exists in a collection or what certain institutions represent. And I don't mean to focus too much on Howard or on specific individuals from there, but it's a really rich area, and there happens to be a lot of data, so it's a pretty good example to use. But you can easily switch out Howard for any other university, or you can focus on any number of occupations or just connections that exist in the world. And again, it is editable by everybody. And so all of these connections and properties came from other community members. So if there's something missing, you can just jump in and add it. So again, this query represents different ways of understanding relationships between people and Howard University. Moving along, I've pulled up this page, which talks about Wikidata statistics. And again, this speaks to research in general because this pie chart shows what is most commonly represented on Wikidata. And if we hover over this largest chunk, you'll see that it is a scholarly article, which is actually this screen down here. Don't get it confused with this screen because they're different. So the majority of things represented on Wikidata are scholarly articles and data about scholarly articles. So it's a huge hub for scholarly information. And there's a lot of different ways to access it, but I just wanted to highlight this for you because not only could it impact the way that you do research, but also the way that your research is represented. And in fact, there is a platform called Scholia that is a good portal into analyzing all this academic research and data. So this is what Scholia looks like, and this is all linked in a presentation, which I hope gets shared to all of you. But this portal will allow you to search for individual people, or individual profiles, whether they're people or institutions. You can see a lot of information about concepts and topics, about specific authors, and you can also search for unique identifiers, so ORCID IDs or DOIs to reference a specific document. And you can just search for anything you want in the search box, not unlike an internet search engine. And so I did this right before my presentation, and I've used Howard again as an example. And what we're looking at is all of these are just query results, but presented in a really neat way. So this top one shows a set of researchers affiliated with Howard and their ORCID IDs, and also a quick description of who they are and what they do. Scrolling down, we can see a co-author graph, so people who have worked together, and I can promise you that there are a lot more co-authors that exist at Howard. This is just what is currently represented on Wikidata. So again, a lot of data needs to be entered into it, but the concept is clear. You can see these individuals have worked together on a certain topic. And again, if we hover over this particular graph, we can go back into Wikidata and see the code and run it and download it. So you can also manipulate this particular graph to show other institutions, universities, connections between people. Very easy to reuse all of this data is the point I'm trying to make. The advisor graph is empty right now because that information isn't there, but if we continue to scroll, you can see the topics that researchers have worked on at Howard. So a lot with biomarkers, COVID-19. I can tell you these numbers are kind of low and there's a lot more research that's happening. Again, this is just what exists currently. And that's what's reflected in these search results. And scrolling down a list of recent publications, there are obviously more recent publications that have come out too, but you get the idea. You get papers and authors, so you can kind of see how the community is doing research and what the focus is on. In addition to that, page production over the years, what exists and what doesn't yet is still being filled out. And citations, so you can kind of track citations over time and how work is developing in that way, kind of like impact scores. And then most cited papers with affiliated first author, scrolling down co-author normalized citations per year. So you can see who's publishing and how frequently, awards that people have won for research. So you can learn a lot about the research context happening in any given university, as well as gender distribution, which tells a very stark story. Every single institution that shows up, you can see the disparity that exists among gender distributions. So this is just a simple profile for one institution. As I mentioned, you can also do this. And so to keep in the anti-racism, and you can see it pulls up some queries too. So this is the topic in context. It pulls in some related concepts and information. So you can kind of see how topics are couched in the world of linked data, Wikidata in particular. Recently published works on a topic. So this is a little more up to date, things coming from February of this year. Publications per year, a big spike in 2020. And again, maybe this is perfectly representative, but there's, I'm sure, a lot of work that doesn't yet factor into these results just because Wikidata is new and continues to grow. Earliest published works on these topics, and then a set of authors who publish on this particular topic, co-author graph, so you can see who's working together in these research areas, other topics related to this, or that co-occur, so things that are published at the same time. And then I think this graph is really important. 400 links. Oh, no, that's just the max. A co-occurring topics graph, so you can see a lot of people writing about similar topics and how they're all related. And again, it's a very global perspective, so you can pull in stuff from all over the world, but it's a nice way to see how things are associated with each other and how the research is developing. And you can also see where this research is happening on a map. Like I said, you can render data points on a map. And if you like this, you can edit it and you can download it and link to it. This is just embedded on a regular old website. And then you can see authors who write in this area and some more topics, some venues, some more citations, more authors, and organizations associated with works about the topic, which I think is also very helpful. So we can click on any of these to see Purdue University has published some of the work, University of Colorado. A lot of these will likely be research organizations and universities. And then if we scroll to the bottom, you can also see awards received by authors who've published on this topic. So it's nice to know culturally where all of these significant works reside. So this whole Scalia platform is really useful for parsing some of the data that exists. Like I mentioned, it can be fully customizable and you can search for whatever you want. I think the data visualization aspect of it is really compelling and important. And it's a really easy way to tell a complicated story pretty quickly. And again, this is just a tiny little slice of Wikidata that exists. But for those of us in computer science who might want to do some more with machine learning, it's really important to know that you can download the whole set of data from Wikidata. You can just download the whole thing, which I think is in the 50s or 60s of gigabytes. And you can just do whatever you want with it. You can run programs through it. You can parse it for specific sets of things or kinds of things. I recently wrapped up work at the University of Virginia with a group who were doing like a classification project with everything that exists on Wikidata, kind of training artificial intelligence to identify what things are. And it's really cool, but it's also really kind of scary because you want to make sure that those tools are classifying things in an ethical way that is representative of the world. And understanding Wikidata is really important to doing that in a good way. And you can bet that because Wikidata is free and open for anyone to use, that other organizations and companies and institutions are using it for similar purposes. So whatever's there, whether it's great or not, is being used to kind of train these AI and doing machine learning projects. And it all is possible because you can just download the whole thing and run your programs through it. So this is, again, the page for downloading Wikidata. There are also other forms of analyses that you can do with the data on Wikidata. So I've been working with a lot of museums and libraries, improving data sets in their catalogs. And I recently had a student, Gina Solaris, write this excellent post about Black Lives Matter data on Wikidata. And she was looking at what exists versus what doesn't using the Scalia platform. And associated with that, a lot of the acts in Congress and kind of modeling the protests and all of the murders and deaths as a result of police brutality last summer and historically. So this is an interesting case study in understanding what exists, identifying gaps, and learning how to fill them. And it's also, as you can imagine, choosing the right semantics around describing all of these things is really, really important and significant, which is why I think interacting on Wikidata is so very important too. And this post that she wrote just kind of describes her exploration into the topic and some conclusions that she drew to improve her library's collection in this topic area. Again, I mentioned that Wikidata supports a lot of what Wikipedia does. And I just wanted to give one last example of how that works in practice. And so this is a wiki project for Black Lives Matter topics and themes. And it exists to improve representation on Wikipedia, this little section that I've zeroed in on, and there are some Wikidata generated lists. And like I said, Wikidata kind of casts a broader net than Wikipedia does and has people who exist in it that might not have Wikipedia articles. This specific list has sets of individuals who do not have English Wikipedia articles, but have articles in different languages. So this is a really easy way to zero in on specific people who could use articles but don't have them yet. And so we can click on Black women in visual arts and see this list here of women who exist in Wikidata, represented here by their QIDs, but don't have Wikipedia articles. So you already have a little set of information to base these articles off of. And I've just selected people because that's an easy concept to have in our brains, but you could switch this focus to pretty much anything you can imagine and generate a similar list through Wikidata's queries and the data that's already on Wikidata, which is very cool. So again, I'm gonna stop sharing my screen. This is my face. You can run these queries on Wikidata. You can do analyses of Wikidata through what exists, what doesn't exist. And you can also just run programming through Wikidata to draw general conclusions about how the community is describing the world, how things relate to each other, and also start to identify gaps to fill them in, which is pretty exciting. And again, Wikidata is free and it's open. And I think the more of us that use it, the better off it will be and the more representative it will be. That said, it's really big and we're just at the very beginning of understanding how to use all of this data. And so I think it's really significant for research because of its accessibility, but also because we just have a lot of questions about it still. So let me just share my closing slide and I would invite you to stay in touch. Feel free to reach out to me, ask some questions. I'm an instructor, so I teach these courses all the time, and I love questions about data and the wiki movement in general. So here's my contact information. Thanks so much for letting me fill your ears during lunch, and I look forward to the question and answer session. Thanks, everyone. All right, one last slide.
Thank you all for watching. For more information on SICSS-Howard Mathematica, visit our website, follow us on social media, and join our email list. Thank you.